Again back to my YouTube channel Sriram Devarajan. Once again I'm going to solve problem from CSI or NET Mathematical Science question paper from the linear algebra. The problem is, let A be a 2 cross 2 real matrix with determinant A equal to 1 and trace A equal to 3. What is the value of trace A square? First option 2, second option 10, third option 9, fourth option 7. This was asked in CSIR NET June 2020. Solution. It is given that A is a 2 cross 2 real matrix with determinant A equal to 1 and a trace A is nothing but 3. We have to find the value for trace of A square. First option is 2, second one is 10, third one is 9, fourth one is 7. Given A, which is a 2 cross 2 real matrix. Since A is 2 cross 2, lambda 1 and lambda 2 be the eigenvalue of A. Since determinant of A is 1 and trace of A is nothing but 3. By well-known result, we have trace is nothing but sum of the eigenvalue. Determinant is nothing but product of the eigenvalue. I am going to use this two concepts for this problem. Trace of A is 3 means lambda 1 plus lambda 2 equal to 3. Equation 1. Determinant of A is 1 means lambda 1 lambda 2 equal to 1. This is equation number 2. We have to find the value for lambda 1 and lambda 2. We know from algebraic formula we can write A minus B whole square is equivalent to A plus B whole square minus 4 times AB. Here lambda 1 minus lambda 2 whole square can be written as lambda 1 plus lambda 2 whole square minus 4 times lambda 1 lambda 2. Lambda 1 plus lambda 2, since lambda 1 plus lambda 2 equal to 3 and lambda 1 lambda 2 equivalent to 1. Substitute these two values in equation 3. Therefore, 3 implies lambda 1 minus lambda 2 whole square equal to lambda 1 plus lambda 2. This is nothing but 3 square minus 4 into 1, 9 minus 4, which is nothing but 5. Lambda 1 minus lambda 2 equal to root 5. Solving lambda 1 plus lambda 2 equal to 3 and lambda 1 minus lambda 2 equal to root 5, we get the values for lambda 1 and lambda 2. Lambda 1 plus lambda 2 equal to 3, lambda 1 minus lambda 2 equal to root 5. By adding these two, this lambda 2 plus lambda 2 minus lambda 2 will get cancelled. 2 lambda 1 equal to 3 plus root 5. Which implies lambda 1 equal to 3 plus root 5 by 2. Since lambda 1 plus lambda 2 equal to 3 and lambda 1 minus lambda 2 equal to root 5, we have to find the remaining one of the eigenvalue, that is lambda 2. Substitute lambda 1 in either of the equation, either in lambda 1 plus lambda 2 equal to 3 or in lambda 1 minus lambda 2 equal to root 5. Lambda 1 plus lambda 2 equal to 3. Lambda 1 is nothing but 3 plus root 5 by 2 plus lambda 2 equal to 3, which implies lambda 2 equal to 3 minus 3 plus root 5 by 2. Simplifying, 6 minus 3 minus root 5 by 2, 6 minus 3 is 3, 3 minus root 5 by 2. Lambda 2 is nothing but 3 minus root 5 by 2. Therefore, lambda 1 3 plus root 5 by 2, lambda 2 3 minus root 5 by 2. Again by result, if lambda is eigenvalue for the matrix A, lambda power n is eigenvalue for the matrix A power n. Therefore, lambda 1 square and lambda 2 square are eigenvalues of A square. We have to find the trace of A square. Trace of A square is nothing but sum of the eigenvalues of A square. Sum of the eigenvalues of A square is nothing but trace of A square. Since lambda 1 is 3 plus root 5 by 2, lambda 2 is nothing but 3 minus root 5 by 2. What is lambda 1 square? 3 plus root 5 by 2 the whole square. Lambda 2 square, 3 minus root 5 by 2 the whole square. Sum of the eigenvalues of a square is nothing but trace of a square. Therefore, trace of a square is nothing but lambda 1 square plus lambda 2 square. Just now we found lambda 1 square. The answer is 3 plus root 5 by 2 the whole square, 3 minus root 5 by 2 the whole square. We can write it as 9 plus 6 root 5 plus 5. Similarly, 9 minus 6 root 5 plus 5 by 4. Simplification. 18, 6 root 5 minus 6 root 5 cancel, 5 plus 5 is 10, 18 plus 10 is 28 by 4, answer is 7. For this problem, option 4 is correct option. Thank you.